I put this walkthrough demo together to show using Volsync for data migration with two MicroShift machines. Source destination machines running in GCP, 8 gigs each to CPU. My local machine is Fedora 35. So here my two GCP machines, I've got the IP addresses and I have a dokuwiki application running. This is the source machine. I am going to migrate the data from the source machine, persistent volume, to the destination machine. MicroShift is a small footprint OpenShift meant for edge deployments, for those deployments that don't have the resources to run even single node OpenShift. Volsync is the tool I will use to migrate data. It's for asynchronous volume replication using Kubernetes CSI storage. In this case, I'll be using Rclone, migrating from the source to the destination for distributing data to edge clusters from a central site. Here we're using AWS S3 bucket as the intermediate. This is what I have running so far. I have installed MicroShift and started the service on the source and destination machines. In this MicroShift service unit file, I have wrapped a podman command. Let me show you how you can use your local laptop or local machine to manage MicroShift. So here inside each GCP instance, I have used the podman copy command to copy the kubeconfig from inside the container to the host. And this is how I've set up access to both clusters from my local machine. With these MicroShift clusters, the certs are set to connect to server at localhost 6443. So I've used the gcloud SSH command to forward localhost 6443 from my source machine to localhost 8888 on my local laptop. Switching to a different terminal, I SCP'd that kubeconfig that we copied out of the podman container to my local laptop at kubeconfig source. You can easily just change that port in your local kubeconfig source from 6443 to 8888 and confirm you can access your remote cluster running in GCP with this kubeconfig. And since we'll need it later, just create a new project. Next, do the same thing with the destination machine, except I'm forwarding to port 9999 of my local host. You can see that you can access the remote cluster running MicroShift. This is a trick for managing both clusters at the same time. I find this very convenient. Merge those two kube configs. In order to use Volsync, you'll need to configure the storage on the source and destination machines. I have deployed a simple dokuwiki example application in my source and my destination. You could deploy it to the source and set up your replication, and once you have the replication created, then you could apply the application to the destination. I'm just doing them both now. So again, from those Volsync documents that I shared earlier, deploy the Volsync operator in both the destination and the source machines. I mentioned I'm using Rclone from the Volsync usage, and Rclone requires a secret. I have a file locally that has this information. Volsync installs custom resource definitions for a replication source and a replication destination. Once you have this setup configured with your Rclone secret, the application's running, Volsync operator installed, all in MicroShift, this is how you migrate your data. We're finally there. Perhaps you have a service writing to your source PVC and periodically you want to send the data to your destination, or you can set up a schedule. So here I'm going to SSH and port forward my localhost 9999 from the destination machine, and I'll do the same thing over here with the source machine and 8888. The source machine is up and running, and the destination MicroShift cluster is up and running. You can see I've done this a few times. I'm going to SCP from destination, kubeconfig dest, and from source, kubeconfig source. Because remember, from the doc, I've copied the kubeconfig out of the podman container running MicroShift on both machines. And I'll copy 6443 for 8888 in the source, and for 999 in the destination. And since I've already created the project, I need to add the context here. And finally, I can rename the context for source and destination. This is how I make my local laptop like a cluster manager. For other purposes, there's Red Hat All Cluster Manager, and I would recommend using that over this, but this is for local development. We're using the source context, so you can see in the dokuwiki app, I'm going to create that replication source. And we'll take a look. The volume snapshot class name is configured. Here's the name of the S3 bucket. I'm going to use copy method clone. That's the most efficient way whenever possible on the source because there's no intermediary persistent volume that's required. Copy straight from the application PV to the S3. The next sync time looks like it'll be in a couple of minutes. You can see I have the dokuwiki pod running. Because I already have the replication source created, the Volsync job has already been triggered, and you can see that the job has completed. So let's check out the replication destination. So here we have this copy method snapshot. Now that I have a latest image, the next snapshot I have it to set every 7 minutes. It's 43 now, and the next one will be at 49. So again, here's the source. This is what it's showing currently, so let's see if we can update it. Let's get the image from the replication destination object. There it is. Need to delete the current PVC. Grab a copy of the definition for the PVC. And you can see. Apply the new PVC. Scale the application up. Wait for the pods to be ready. Refresh. Now we have the source and the destination synced. Let's see if we can do that again. Gonna edit it. Save it. Let's go to the source application. And the next sync time will be, and there we go. Let's go over to the destination. We have to wait till 56. And there it is. There you have it, Volsync and MicroShift migrating data.